Going on in the Chapter 3 textbook for 8th grade, we are going to be working on 3.4. So you have these notes with you. You can stop, pause, replay, whatever you need speed-wise. If you don't understand something, make sure you circle it. Come in tomorrow with questions. So here we go. 3.4, solving for a variable in a two-variable equation. Today you will recognize a couple of familiar formulas that contain two variables. We are going to solve for one of them in this equation. So example number 1, the perimeter of a square, well-known formula. The perimeter is adding up the four sides or 4 times the length of one of the sides. If P is 18, if we know the perimeter, can we find the length of the side? This is an L here, by the way, not a 1. So if we know the perimeter is 18, can we find the length of the side? So we write the formula, perimeter is equal to 4 times the length of that side. I know what it is. It's 18 is the perimeter. Equals 4 times what length? Well, very simple. Solving a multiplication equation, we use the inverse, which is division, and we get 4 5/10 equals that length. Did they give me a unit? No, so it's 4 5/10 units is that length. It doesn't say centimeters, yards, miles, so we call it units. Now let's solve the equation for, oh, I did that. Let's solve the equation for length. I did it over here. Whoops. Okay. Next example, example number 2. Temperature conversion. If you've ever traveled to Toronto, maybe to see a Yankees game or a Blue Jays, or to see the Buffalo Bills play in Toronto. The conversion is Fahrenheit. If you know the Fahrenheit, you can figure out the Celsius. Let's solve for the Fahrenheit. So, if I want to know, this tells me Celsius. Celsius is equal to 5/9 times the quantity, put in the Fahrenheit degrees that you know, subtract 32, take 5/9 of it, and you'll figure out Celsius. Well, what if I want to know what's the Fahrenheit? What if I want to know what's the formula to find Fahrenheit knowing Celsius? So that's what it's asking me to do. Solve this formula and get the Fahrenheit F on the one side by itself. Let's solve for Fahrenheit. That's what that's saying. So I start with the Celsius formula. 5/9 times the quantity of Fahrenheit minus 32. And yes, those are capital letters because it's a well-known formula. And formulas usually have capital letters in them. First thing I would do would be to clear this rational. So I'm going to multiply both sides of the equation, whoops, by the multiplicative inverse, forgot to invert it, by the multiplicative inverse 9/5. So then I can cross cancel my 5/9 and my 9/5, and I have 9/5 of Celsius is equal to, I don't need those parentheses anymore, Fahrenheit minus 32. Well, if I add 32 to both sides, I'm going to get my F all by itself. Yes, it's on the right side, but that's okay. So if I take 9/5 of a known Celsius temperature, add 32 to it, I'm going to get Fahrenheit. So you could turn it around because it's reflexive. Fahrenheit is equal to 9/5 of the Celsius degrees plus 32. Doesn't matter what side the F's on. So solving that equation for both Fahrenheit and Celsius. So we now know that 9/5 Celsius plus 32 is Fahrenheit. Let's create a table of values comparing Celsius and Fahrenheit values. What if the Celsius is 10, 20, 30, or 40 degrees? Yes, these are degrees. Let's pretend there's degree or write in a degree symbol there. So if I know the Celsius, can I figure out the Fahrenheit? So 9/5, plugging in C is 10 at first. So plugging in C is 10 plus 32 will give me my Fahrenheit. Well, 5 does nicely cross cancel into 10 twice, so I get 18. 18 plus 32 is 50, so my Fahrenheit degrees is 50. If the Celsius is 20, notice I picked easy values to solve this for. because I know they're all multiples of 5, so I'm going to get some cross-canceling here. So 5 goes into 24 times, so I have 36 plus 32, which is 68 degrees Fahrenheit. So 20 degrees Celsius is 68 degrees Fahrenheit. This is considered room temperature. It's a common, in America we say 68 degrees Fahrenheit is room temperature. In European countries they say 20 degrees Celsius is room temperature. 30 degrees, same steps that I did with the 10 and 20, 9/5 times 30 plus the 32 will give me the degrees Fahrenheit. Plus, I know 30 is 3 times bigger than 10, so I could figure it out that way too. 9 times 6 is 54, plus 32 would give me 86 degrees Fahrenheit. So a 30 degrees Celsius day is an 86 degree warm Fahrenheit day. 40 degrees, okay, 9/5 times 40. Again, it's going to cross cancel. We knew that. Oh, we can put it over 1. If you like doing that, feel free to put it over the 1. I don't, as you can see, most times I don't. 72 plus 32, oh, that's about 104. My daughter Heather is now out in Arizona, Lake Havasu, Arizona, and they're still having 100-degree temperature days. So a very warm day in Canada, for instance, would be a 40 degrees Celsius day. For us, 104, very warm day, hot day in Arizona, 104 degrees, although it gets much hotter than that. Next example, let's solve for x in terms of y. So there's still going to be a y in the equation, just like when I solved for Fahrenheit, there was still Celsius in the equation. Solve for x. Leave it with a term of y in it. That's basically what that means. So I've got to get x in this equation all by itself. Well, the first thing I would do is go ahead and distribute. So 2x minus 6 equals 3y minus 1. I'm going to add 6 to both sides. So that's simplifying this subtracting of 6 from the x. So 2x equals 3y plus 5. Well, I don't want 2 x's, I want just x. Solve for x. So I'm going to divide by 2. I have to divide all of this by 2. So my answer is just that. I can't simplify this because I don't know what y is. 3y plus 5 all over 2. So that binomial over 2. That's as simplified as it gets until I know what y is. Now substitute y equals 3 and find what x is. I have to be told what that y is to figure this out. So y is 3. So my x equals 3 times 3. Substitute means you have to show that step. Can't jump to 9. You got to show 3 times 3. Common Core requires that. That's what substitute means. You're showing that you understand that vocabulary word if you do that. 3 times 3 is 9, plus 5 is 14. 14 divided by 2 is 7. So x would be 7. So when y is 3 in this equation, x would equal 7. One more example. Solve for x in terms of y. Well, this is solve for y in terms of x. This equation is solve for y with an x in it. We've got to do the opposite. We've got to solve it for x and leave it with a term of y in it. That's what that means. So first thing I would do would be to multiply by 2. Let's clear that rational. So I get 2 y's, these cross cancel, equals 2x plus 3. Got to get that x by itself, so I'm going to subtract 3. 2y and 3 are not like terms, so I have this binomial. 2y minus 3 equals 2x. I'm running out of space here, so copy it over here. 2y minus 3 equals 2x. Dividing by 2, I get the binomial 2y minus 3 all over 2. That's as simplified as it gets, equals my x. Find x when y equals negative 13. Okay, 2. Can't say negative 26. You got to show 2 times negative 13 minus 3 all over 2. I know you want to do it in your heads, but you got to show that substitution. 2 times negative 13 is negative 26. Negative 26 minus 3 more is negative 29. Negative 29 over 2 equals x. I'm going to leave that rational. I could change it to yes, negative 14 and a half, but I'm going to leave it rational, negative 29 over 2. And that's it for today. We're going to practice some more solving equations for one variable, given that they're a 2-variable equation.